This is our first homework in discrete mathematics, chapter 1, and as you can see, the first exercise, first see on the bottom half of my paper. I guess you all know the basic operations, logical operations like disjunction, conjunction, and inverse. And in order to solve the first exercise, we have just to make a truth table, and I think it's just self-explanatory. And over first exercise, we have the fifth one, fifth A, and also in order to solve this exercise, we need to show that P disjunction Q, P conjunction Q, this given statement is a tautology. In a truth table, the only time an implication is false is when the first part is true and the second part is false. But since P disjunction Q is stronger than, but since P conjunction Q is stronger than P disjunction Q, every time P conjunction Q is true, P disjunction is also true. The result is always true, meaning the statement is tautology. This is an explanation for the fifth exercise. So let me then show the last one. It's right here, 1Z. I hope you can see it. And the explanation is that the given statement, we have to rewrite it, and substituting this with statement simplifies using the De Morgan's law. And at the bottom, there should be the final and simplified form of the expression.
In the first task, number E, we need to find all solution of this expression, P implication Q implication R, implication to P conjunction Q, disjunction R. To find out all possible solutions of this expression, I use truth table method. As a first action, I choose Q implication R. The second is P implication to this expression. As third action, I used this P conjunction Q, and pre-last action is this expression to disjunction R. As a result of all of this expression is this truth table. It's tautology just because all possible answers of this expression is true. In the fifth, we need to show that P conjunction Q implication to P disjunction Q is tautology. As method of solving, I use to equivalence. P conjunction Q implication P disjunction Q is equivalent of negative P conjunction Q disjunction P disjunction Q, and the equivalent of negative P conjunction Q is negative P conjunction negative Q disjunction. And the results of this expression after all equivalence is when P or Q is true, so whole expression will be true because of all solutions of disjunction. So it's tautology. In the B variant, we need to show that this expression is contradiction. If P is false and Q is true, so P disjunction negative Q becomes false because of disjunctions solutions. Therefore, the expression will be always false because P disjunction Q is negative Q is false, and this conjunction makes all possible variants of the solution false. So it's obviously contradiction. In the sixth task, number A, we need to show that Q implication P implication Q is tautology. I also used equivalence. The first equivalent is Q implication P implication Q is equivalent of negative Q disjunction to negative P disjunction Q. and equivalent of this expression is negative q disjunction q disjunction p, because as answer, because negative q disjunction just normal q always will be true, so the whole expression will be true because the all actions are disjunction, and we just need only one true variant among these possible variants. So it's obviously tautology. In the B variant, we need to show that expression P conjunction Q conjunction negative P to disjunction negative Q is contradiction. I also here used equivalent as an equivalent of negative P disjunction negative Q is negative P conjunction Q. If P or Q in these expressions is false, so the whole expression will be false because of negative variance of P conjunction Q. Because when these two are true, in the variant where these two are true, the negative expression of this will be false. So every possible variance of solution is false. So it's a contradiction.
So we take this equation as an A and the second one as a B. And here we can see that the given problem lies under the absorption rule, so we can directly use it, and by this we can prove that this one equals to the second equation. And in the next one, on the first one, we use this implication method. So this implication can be simplified like this, and as we see here, the equation simplifies to this one and this. And on the second side of the problem, we use the same method. So this one becomes this, and on the next step we have to use De Morgan's law like this, but here the end side and symbol becomes the or symbol. So by doing this we can see that these two sides of the equation are the same. And the next problem, on the first step we have to use the De Morgan's law again, and this equation so becomes this. And the next step is here we can see that those two brackets have the same element and it is not P, and by this this one becomes this, and here in the bracket we can see that this equation always gives us true. This is tautology, and that's why on the final step we have not P and 1 means true, and this gives us not P always. And here we prove that those two sides of an equation are equal to each other.
So this is section 2, number 9. So in this exercise we should determine is it the expression in DNF formula. So in the D expression there is P and Q, or not P and not Q and R. So we should determine is it this expression in DNF. So first of all, we should start with this first small expression, P and Q. This is a conjunction. Then not P and not Q and R, it's also conjunction. So this is a disjunctions of two conjunctions. So this is in DNF formula. So the next one, it's E expression. It's P and Q and R, then or not P and not Q and not R. So the first expression, small P and Q and R, it's a conjunction. Then not P and not Q and not R, it's also conjunction. So this is disjunction of two conjunctions. So this is expression in DNF formula. So the next exercise is 10. In this exercise, we should express equation in DNF formula. So we start with D. There is like P, not P or Q, P and P or Q and not P or not Q. So in this equation, we can apply a distribution rule. So A or B and C or D, it's like we can open it. It's in this big equation. So we can just imagine that A is a P, B is a Q, C like no P, and D like no Q. So we just apply this big formula, this big rule for our expression, and then we have this is big another expression. So there is like P and not P, or P and not Q, or Q and not P, or Q and not Q. So how we know P and no P give us false. Also Q and not Q, it also will be false, based on the rule. So we just simplify it, and then we get this small expression. So there is like P and not Q, or Q and not P. So this is equation in the DNF formula, because it's a disjunction of conjunction. Disjunction is this, and conjunction it's like and. So the next one, it will be F. In this exercise, we have P or Q and P or not R. So we also can apply distribution rule, but another version. A and B or C, we can express like this. Okay, so there is we can imagine that A it's a Q, B it's a P, and C it's a not R. So applying this rule, we can see that there is Q and P, or Q and not R. So we can simplify it like this. P or Q and P, or Q and not R, like in this rule. So how we know P and Q or P give us just P, so we simplify it like this, and then we have DNF formula also, because it's a disjunction of conjunctions.